Hello and welcome to this clip looking at how we can extract iron from a match head. This is a practical we've done here in college in our chemistry society, and it's a straightforward redox reaction in which the iron and the iron 3 oxide that can be found in a match head can be extracted. So the reactions are quite similar to those found in the blast furnace. So at the bottom of the blast furnace you have hot air pumped in, and you have carbon, or coke as it's called, which is oxidized by that hot air. So that makes carbon dioxide. So a little bit further up the blast furnace, in the melting zone, what happens here is the carbon that we've had before as coke is oxidized by carbon dioxide that we've just produced by oxidizing some of the other carbon. So that gives us carbon monoxide, which is a reducing agent. So the iron is reduced from +3 in iron 3 oxide to 0 in iron. And you'll notice it says it's the melting zone. So this is happening at such a high temperature, 1250 degrees C to be exact, that what happens is the iron melts and it sinks and can be tapped out in the tap hole, as you can see on the left-hand side. So let's now consider how this might work if you're doing it with a match head. Obviously a match head is the same reaction but at a much smaller scale. So the first step is to prove that iron 3 oxide is non-magnetic. So you can see from the photograph that the magnet is not picking up the iron 3 oxide on its north pole. So the match head is dampened, and then that can be used to hold the iron 3 oxide. So technically it's not necessarily iron 3 oxide that's in the match head, but it's the match head is dampened so it can hold some iron oxide on its surface, and then the wood in the iron oxide can be used as a source of carbon. Now this happens at much lower temperatures than the reactions we talked about a moment ago, and basically to get around this problem we use a sodium carbonate catalyst to help the reaction along at lower temperatures. The match is now burnt at around 600 degrees Celsius. This is our strong flame on a Bunsen burner. So it's about half the temperature you'd find in a blast furnace. And the organic material in the wood itself will end up as carbon, and the carbon can start the reaction sequence on the left. So you can run a magnet underneath the iron 3 oxide and the iron to prove that the iron must have come from the original iron 3 oxide.